Hey guys, welcome back to the next video. In this video, we are going to talk about horizontal pod autoscaler architecture. To understand this architecture, we need to understand from the control plane's perspective. The horizontal pod autoscaler, or HPA, shortly called as, is primarily managed by Kubernetes API server. Now, the API server is responsible for receiving requests to create, update, or delete horizontal pod autoscaler object. And it is a specific configuration, like what we have seen before in terms of the previous architectures. So the resource was actually part of an existing container configuration. So is the previous ones which we have seen, as in like the name, node selector, or the node name is all part of an existing architecture, which is actually having your horizontal, which is having a different API server call. If you can see that this is a API server call, which is pod, and here this is a replica set. But when you're configuring a horizontal pod autoscaler, it itself is a kind, which means that it itself is an API, which exists on the API server. So what you're going to do is like normally what we would do is like we will target an application over here by giving the name of the application. For this example, I've given the replica set name over here, where this will be targeting a replica set which is configured either within the same file or on a different YAML file. So this is a separate API server configuration. So which means that it won't be utilizing an existing, resource call or API call, but rather it would be utilizing the its own API call, because it is own API services available, which is called horizontal pod autoscaler. That's the first thing you need to understand. The API server is responsible for receiving, creating, and updating all these horizontal pod related stuff. So whatever you do over here as part of this one, you can actually create as a separate service. You can create, delete as a separate service using kubectl. And then you can also get information about the horizontal pod autoscaler because it is an API service. When you create HPA object, the API server stores the configuration in etcd. So this is the second step. Now that the stored configuration will be on etcd, the distributed key valve store used by the Kubernetes primary data store. So it's going to use the same key files. The API server also watches for changes to the resource utilization metrics specified on the HPA, such as CPU and memory. So these are the use cases. So only two use cases are there for HPA or horizontal pod autoscaler. One is either using this particular memory name, or you can use the CPU name as a resource type. In response to the changes in the resource utilization, the HPA controller, which runs as part of your control plane, periodically evaluates the current state of the cluster and compares it against the desirable state behavior specified in the HPA object. If the observed resource utilization exceeds or falls below the target threshold defined in the HPA object, the HPA controller triggers the scaling event by adjusting the number of replica by either increasing or decreasing the number of pods or replicas which needs to be taken care or being populated. In summary, the control plane component responsible for managing the horizontal pod autoscaler are primarily in Kubernetes API server and the HPA controller. So this is something which you need to understand before we proceed, before I start explaining about little details over here. Let's go in depth and try to understand what this does. So firstly, you need to understand the difference between the previous architecture which we have seen towards resource request and limit is much different than what we're going to discuss over here as part of workload management for HPA. Now, This is all about scaling. So it's either scaling up or down. Okay, so that's basically not just about the resourcing component, but it is based. The scaling will be based on the resourcing component. So there'll be another additional component which we need to review over here on this video. So that's what we are going to look at in this video. So as you can see over here, horizontal pod scaler over here will be scaling up and down based on the resources. Okay, so now let's just understand the YAML file from the beginning, because this is the first thing which gets triggered. So as you can see here, this is the API version. So you need to go to API server to understand the versioning and the kind information. So I've already given here. You don't have to do that. All right, so now here you can see the metadata name here is the my app memory autoscaler metadata. So sorry, the name for the metadata, which is basically the name of your horizontal pod scaler. And within that, you have a specific scope in which we are actually targeting a scale target reference over here. Now, you use the scale target reference to target a replica set. So now here you are giving a replica set over here, which is a replica set as a kind. You're giving a version of it and you're defining a name of this replica set. Now, in this replica set, you are defining what under the specification, you're defining the minimum replication and maximum replication over here. Now, what do you mean by minimum and maximum replication, if you ask me? So this tells you that the minimum number of servers should be always available is 1, and the maximum number of servers which should be always available is 10. These are the two framework which we have to go forward with this configuration. Very simple one. So which means that if there is a requirement, this particular HPA can create instances or pods with having a number of 10 pods running at the same time. And if there is not much of activity, it can go to a minimum of 1 pod running at a given point. Now, how it's going to define this, how it's going to say that there is a high load or low load on the system is by using the metrics. Now, metrics is using the kubelet. It was going to collect information from the running pod, and it's going to collect that information. Now, what information it collects? It collects the resource information called memory resource. Here in this situation, we are giving memory over here, and what we are trying to look for, we are trying to look for target average utilization. All right, so there are this two items over here in terms of resources monitoring. One is memory, another one is CPU. Now both has target average utilization over here. One is at 80, another one is 50. Now let's just try to understand what is target average utilization is. So this is a parameter that specifies the target average utilization of resource metrics from the pod managed by HPA. It's used to define the desired level of utilization for a specific resource, such as CPU or memory. For example, that if you set this CPU, let's just say, for example, if you set the CPU utilization as a 80%, so it means that if you want to have an average CPU utilization across all pods managed by the HPA to be 80%. So if you set the target, in terms of like memory utilization, you set a target of 50%. It means that on an average, the memory utilization of all pods managed by HPA should be 50%. So when the actual resource utilization exceeds, like in this example I've shown you, so CPU is at 50%. So if the CPU utilization goes beyond 50%, then it is considered by the HPA that it is a breach of the average utilization. Then what it does is like it spins up another pod it spins up, and then it sets the same average utilization for that pod as well. So the moment this pod also reaches an average utilization more than 50%, then it's going to create another pod. So likewise, it's just going to create new pods based on the utilization what you have defined over here. So if you're like running like 5 pods right now, because all 4 pods have the average CPU utilization more than 50%. So you're running 5th pod. So now what happened is like the first pod which was created is having reduced CPU utilization. So what it does is like it terminates the pod which is below that specific requirement, and it sees that there is no need for it to have more pods running when the average utilization is below the average utilization. So it keeps as and when the pod reaches from the 50% to down, it's gonna remove those pod one by one until you have only one pod as a minimum replica over here. So it's always gonna have one pod, running all the time, unless and until it requires new pods because the average utilization has been breached. So this is a kind of a scenario where I want to take you and show you on the hands-on session how actually it is implemented and how these new pods are being created on the hands-on session. Thank you again for your patience and time. I hope that this video was helpful for you to understand how it was able to use. So both memory and CPU goes in over here, and then the API server connects with kubelet and basically looks at your CPU and RAM and assign new pods if it breaches that specific targeted average utilization. All right, guys, that's all I have for you in this video. I'll see you on the next one.